All right, stat students, we're going to do a quick review over a few questions that were asked by a student for the problem set. All of us have switched to distance learning at this point, so I've been able to put a little more time into my recording here. So I added a cool little intro, and we'll have some background music as we watch this. So let's go ahead and get it started. Alrighty, so we are going to be looking at several questions inside of this review. The first thing that I want you to note is that we are going to omit 51, 52. I've already said that to you all, but we're actually going to go ahead and get rid of 53 and 54, okay? Nowhere in AP or dual credit does it show these. I should have gotten rid of them to start. But it's okay. If you are honestly curious about what these are, I can make a separate video instructing of it, but I'm not going to make it the main focus for everybody. Okay, so ask me if you have questions about that, okay? All right, so let's go ahead and start with the first question. So the first question we're looking at is number 30. So as I'm working these, you can be writing along with me. Now I don't have my answer key at home, so I'm pretty sure what I'm going to be confirming is correct. I just worked through them myself before I made this video and got the answers I got. So let's just make sense of these. I know I feel pretty confident about number 30 here. So on this question, it says items produced by a manufacturing process are supposed to weigh 90 grams. The manufacturing process is such, however, that there is variability in the items produced. And turn down some of this music. Okay. And they do not all weigh exactly 90 grams. The distribution of weights can be approximated by a normal distribution with a mean 90 grams and a standard deviation of 1 gram. About what percent of the items will either weigh less than 87 grams or more than 93 grams? So we have not done a problem like this in any practice. This is meant for you to think about. So I'm really bad at drawing these normal curves on my Mobi. So you're going to see that as I'm working through them. So all you need is a simple diagram, so I'm not really going to sweat over it. 3 deviations above, 3 deviations below. So we know it's 90 grams in the center. Deviations by 1, so we're going to go 91, 92, 93, 89, 88, 87. Now it wants to know weighs more than 93 grams, or, so that's a big statement here, or less than 87. So we want these two areas here. Now, we took notes over what these areas are. If you refer to your note sheet or what we have written about these different areas, we know that this is 0.15% and this is 0.15%. So combined will give us 0.3%. So B would be the best choice on this question, okay? So it's just using the idea of the areas within. All right, there's that one. Let's go to the next question that was asked. Number 33. So on this one, if the heights of 99.7% of American men are between 5'0" or 5 foot nothing and 7 foot nothing, what is your estimate of the standard deviation of the height of American men? So we're going to go ahead and when it tells us that it's 99.7, we're assuming that they're talking about a normal distribution at that point. So we're going to use a normal distribution to help this. Also, heights of American men, heights are a distribution that are going to be approximately normal always. So let's go 3 above, 3 below. 99.7, remember that is 3 deviations above and below. So that means I'm going to put 5 foot 0 here, inches there, 7 foot 0 inches here. Now here's a big part of these. Again, a lot of this is not within our notes. And I like that because I want you guys to think a little bit more about how you would set these questions up. This is meant to be sort of a problem-solving approach independent of me. So I'm glad that I have a student asking questions. It's going to help everybody out. Okay, and that's really what the point is. I want you guys to be asking questions when you get them. So we know that there's symmetry here. So what that means is if this is 5 and this is 7, the center of that, since these are equal distance from the center, has to be 6 foot 0 inches. Now, it goes up. Now, I won't say the area goes up proportionally, but these values on our horizontal axis, the x-axis, are going to go up by an even amount because these are deviation. This is 1 deviation below, 2 deviations, 3 deviations below. So 3 deviations below is 12 inches. That goes either direction. So 12 inches up or 12 inches down is 3 deviations. Well, I go 1, 2, 3. So I need to divide that by 3 and I get 4 inches. So this would be 6 foot 4, 6 foot 8, and then that would give me a 7 foot. So we know that we're going up or down by 4 inches. That would look like this over here. So it'd be 5 foot 4, 5 foot 8. Okay, so 4 inches is the deviation. So we're just using our understanding of the composition of a normal distribution and its parts. The next question that was asked was 35. 35 looks very challenging. It does. I know that. Let's just talk through it. Really, this is a definition. It's saying, I'm not even going to read the whole scenario, okay? It says, explain to a friend what the standard deviation roughly means, using the fact that changes in mutual funds value over many years have roughly normal distribution. Okay, so we're looking for the best answer. This is one of those questions that's difficult because there's so much here, but we're looking for a true answer. So this A, the standard deviation is the distance between the lower and upper quartiles. So it spans half the yearly changes in the fund's value. This is not true. Standard deviation is not the distance to the lower and upper quartiles. We're going to get into that in a second. Never said that. Remember, in a normal distribution, it goes 68% of the data is 1 deviation. Okay? Quartiles are the middle 50%. So it's 25% above, 25% below. So this is not a true statement. So we're going to X that out. The standard deviation is the largest change we ever expect to see in a year. No, it is the average change, the average distance from the mean. It's the average spread or variation. So that is not a true statement either. The yearly change in the fund's value will be greater than the standard deviation half the time and less than the standard deviation half the time. So this one is not true either. We never guarantee that, okay? Average doesn't mean that it's half the time it should be above, half the time it should be below. In this case, you know, it varies so much, we're not really sure, okay? Not really sure. Next, D, start with the average change. The average change in the fund's value over many years, the actual change will be within 1 standard deviation of that average in about 68% of all years. This is the most true statement here because within 1 deviation, you're going to get 68% of the data, okay? Which this next one, E, is saying 95% is within 1 deviation. So that's why that one's not true. So D is the best choice. This is a challenging question. A lot of times on these problem sets, you're going to have more challenging questions than what will actually be on our test, and I want that. Okay, I want you guys to be thinking about these problems to get better as in statistics class. All right, next question, 41. So this one is using the idea of a normal distribution. Hold up, there we go. So it says a soft drink machine can be regulated so that it discharges an average of mu ounces per cup. If the ounces of fill are normally distributed with a standard deviation of 0.4 ounces, what value should mu be set at so 98% of the 6-ounce cups will not overflow? Okay. So this one is more obvious than you think. It seems very difficult because we have this unknown mean. But we know that we're going to be adding. So plus 0.4 ounces plus 0.8 ounces plus 1.2 ounces. Okay, now for any of these, we know that any of these values are going to overflow. But I want you to think about this. If we set the mean at 6, what's going to happen immediately within 1 deviation? That gets us 6.4. It's already overflowing, right? And where is 98% going to fall? Remember, this is a percentile here because it's saying 98% of 6-ounce cups will not overflow. That's what it's saying. Okay, well, if we go from we know from here, from one deviation back, if we add up all the area, we know it's 50% to the left. So this is 84% for one deviation. So it's already overflowing. It didn't even get to 98%. So it can't be this. Now think about the rest of these. Are any of these going to work down here? No, no, no. So by process of elimination, 5.18 is going to be the best choice for us, because if we do 5.48 or 18, we get 5.58. Excuse me, yeah, 5.58, 5.98. So already within 2 deviations. So if we added this area, I think this is 13.5%. So that puts us at 97.5%. So then, it's not going to overflow. We imagine 98% is going to be somewhere in here somewhere. So that should work. Obviously, it's closer than any of the others, truly. Okay, so A is the best choice on this one. All right, we have 2 more questions we're going to look at. So let's go to 47. All right, so we have the 5-number summary of the distribution of 316 scores on a statistics exam. It gives us 0, 26, 31, 36, and 50. So we had to remember what 5-number summary is. It's going to be helpful. The scores are approximately normal. The standard deviation of the scores must be about. So we're going to think through this. One thing that's very helpful here, we know that this is the median. And in a symmetric distribution, the mean is equal to the median. So that's going to be the first idea that helps us. So we know that this has to be 31 if that's the median. Now, if we go 1 deviation, this is what we're looking for. We're going to get our value. Now, we know that between here is 68%, but this is not the IQR, because remember, IQR, Q1 minus Q3, that's 50% of the data. That's the middle 50%. So that's going to be like from here to here. So this is, we'll say this is 26, and this is 36. Now that means we can eliminate some answers right off the bat, because 1 deviation can't be 0.67. It's not going to add to that 1 marker there if we already know that this goes up 5. That also means it can't be B, because if we go up 5, we've only gone a quarter of the way up. We need to go up 34%. Okay, so it can't be that one. It can't be E. As soon as I add 55 to 31, we're going to go all the way up to 86. The maximum is 50, right? So this is actually impossible. It can't be 55. Now, what about 10? Well, if we go up by 10, we get 41, 51, and we're already exceeding the max within 2 deviations. We have exceeded the max. So that seems not correct when you think about it. This is now 61. So in 3 deviations, it seems very unlikely that that's going to be correct. So that leaves us with 7.5. If I go up by 7.5, I get 38.5, 46. Okay. I believe I'm doing that math right. Yeah, that's right. Yeah, 46, and then go up by another 7.5. You're at 50. Can't math right now. 53.5. There we go. Now this does exceed the max, but it's not as extreme as, say, the 10. This one would be the best answer. Okay. Then we have the last one down here. I'm just going to go ahead and work it. So 48 was the last question that was requested to look at. So it says you're chatting with the principal of a local high school. The topic of SAT scores comes up, and the principal mentions that SAT scores at the school are normally distributed. And if we remember our ACT scores, we've looked at some of that data. Ours weren't perfectly normal, but it was approximately symmetric. Some of them it was slightly skewed right, but it's close. But anyway, she doesn't remember the mean or the standard deviation, but she does remember that the upper and lower quartiles are 500 and 600. Standard deviation of the SAT verbal scores is closest to. So we're going to draw our normal distribution again. this idea of symmetry is very helpful. I'm going to go ahead and just do one deviation. We know that the quartiles, so this is Q1 and Q3, we know that those need to be in the middle 50%. So this is 500, this is 600. And since this is symmetric, we know the middle has to be 550. Now this automatically is going to rule out two options, A and B, because these can't be deviations, because 25 is too small to even get to the quartiles. 50 gets us to the quartiles, so it can't be those. 550 is going to be way too big, okay, per deviation. It doesn't really make sense, okay? 100 is also a little bit too large. All right, remember, we've gone 25%, we just need 9 more percent to get that 34%. So it makes sense to do 75 as the answer on this. This is the closest one that we could probably get to. It may not be exact, but it is pretty close, okay? So that's the last question that was requested on here. Hopefully that is very helpful. We are going to be turning in these grades today, or these study guides. If you have any last minute questions, make sure you email those to me, and I'll do my best to get those answered. Hopefully you enjoyed the video with the music and all that. So able to add a little more production value to these. I'm going to go ahead and stop.